All right, so let's start the class. Can you hear me? Yeah, if you don't hear me, let me know. So today we're going to continue study same type of problems for a sequence of numbers, but this time the sequence numbers show up in pairs or in maybe in groups. Okay, so we need to pay more attention to all possibility now, right? So let me discuss the first problem, and some of you already gave me the answer. Right. Yeah. So the first couple problems are similar to the problems we discussed before. So take a look at those four pairs of numbers. What you find out is the sum of the numbers in each pair is always the same number, which is going to be 11. Okay, so if you notice that, then the problem is simple, right? So 10 plus 1, right? 10 plus 1 equals 11, and also equals 9 plus 2 and 8 plus 3. So therefore 7 plus some number, right, should be equal to 11, and that number is going to be 4. Okay, so plus some number, right? So clearly that number is going to be 4. So that's great. Then you look at the second problem. The second problem, we have a sequence of 4 pairs of numbers, right? And so now, right, look at this pair of numbers, and if you add them together, you find out you get 4 numbers that there's no pattern you can figure it out. Okay, so 17 plus 16, 14 plus 10, 12 plus 4, and some number plus 2. Okay, sometimes, yeah, if you add them together, there's a pattern that they decrease by same number each time. But this one, I don't see it. It's possible now, right? You can check that. Okay, so there are a couple ways. If we add them together, right, 17 plus 16, that is going to be 33, right? Add them together, 17 plus 16, right? And 14 plus 10, you get 24. And then 12 plus 4, you get 16. Okay, so so it's and I don't see there's pattern among the 3 numbers, so there's no way you can get that. Sometimes, yes, there's a pattern. You say, oh, this is every time it's decreased by a certain number. Okay, so you put a question mark here. It's not stop. Then you see that you take the difference, right? Addition, multiplication, subtraction. So 17 minus 16 equals 1. 14 minus 10 equals 4. 12 minus 4 is going to be, right? 12 minus 4, no, let me check, okay. 10 minus, did I type it wrong? I think it's typed it wrong here. I'm sorry for that. This is impossible to solve. Nobody get it, right? Yeah, I think that's typed. There's some mistakes here. I'm gonna copy it. Okay, so so maybe the other methods work. Now it's working, okay. So I'm going to get, okay, that's a 17. Okay, so that's still not working here. So let's see. So 13 minus 14, minus 4 is going to be 9. Okay, then you see this is a pattern, right? So you can see that, right? Yeah. So some number minus 2, and that should be equal to 16. So that implies That should be 2 plus 16 is 18. Okay. Okay. Yeah. I don't know why I copied wrong. Okay. So it's 13, 4, then that works in. So this is a sequence of a square, perfect squares. Okay. This is a sequence of perfect squares. Okay. Now, if you use addition, you don't see any patterns here. Okay, 33, 24, 17, because if you look at that 17 to 14, 14 to 13, right? And another 16 to 10, 10 to 6. So yeah, so addition does not work. Subtraction works. Okay. And now let's deal with a triple of three of three numbers. Okay. So we have here three circles. Each circle they have three numbers there, but the last one, there's one number is missing. Okay. Okay, there was one number is missing. Now let's try to figure out that number. Okay. You focus on the three numbers in the first circle. Well, there are many possible relationships among them. Okay. And then you look at compare, yeah, this same relationship should be carried over to the next one. Okay. So you notice that, okay, either 60 divided by 5 is 12, or 5 times, 5 times 12 should be equal to 60. And you double check that here, 4 times 20 equals 80. Okay, so therefore 8 times 30 is 240. That should be the answer. Right? Yeah, that makes sense. So usually, yeah. So usually, there's the same mass, same we call the operation is carried over to the next one, right? Using the same operation. Okay, 8 times 30 should be 240. Now, sometimes you have multiple choice, multiple answers. Okay, maybe another student come up with a different pattern, then also makes sense. Then you have two answers. But this particular one, I don't see any as a possible way to get number different from 240. All right. All right, so I'm going to ask you to do the next problem. Okay. So 3, 6, 18, 5, 12, 60, and 7, 18. Okay, so what do you got? All right, so we also notice that it's a 3 times 6 is going to be 18. 5 times 12 is going to be 60, right? So 7 times 18, that's going to be 126. 126, okay? 126 should be the answer to that problem. Okay. So the third number is a product of the two numbers. Okay, so that would be the answer. Got it? How about next one? 3, 9, 6, 5, 12, 30, 7, 18. Okay. Wow, that's slightly different. Okay. Okay, great, Morgan. Okay, so this picture is similar to the above one. The only difference is here is 9, 30. So what we do here is actually is 3 times 6, and it's going to divide by 2. It's going to be 9. Okay, you have to divide by 2 each, the third number. Here's a 5 times 12, divided by 2 give you 30. So it's 7 times 18 divided by 2, right? And that is going to be, that's going to be 63. Okay, so that's a be 63 instead of 126. Got it? Yeah. All right. All right. So we apply the same operation we call algebraic operations for the numbers in each circle. Now, sometimes, okay, sometimes probably all those circles are related. It's not just separate numbers and they apply the same operations. Okay. And so take a look at this one. I have two numbers missing here now. Okay. I have two numbers missing. So take a look at the 9, 12, 36, 12, 16, 48. Okay. Okay. So the relationship for the numbers in the first circle should be carried over to the numbers in the second circle. Okay. So 9, 12. Okay. 9, 12, and 36. Nine, 12, maybe there's a ratio, right? But the 12 and 6, 12 and 12, right? And 36 is multiplied by 3. And the 9, from 9 to 36 is multiplied by 4. Okay? And let's see if that is true, the same. It's 12 multiplied by 4 is going to be 48. And 16 multiplied by 3, you get 48. Okay, great. So you will do the same way. This 15 multiplied by 4, right? That's gonna be 60, and some number multiplied by 3 should be 60. So that number is gonna be 20, I think. Yeah, 20 multiplied by 3 is gonna be 60. Right? Now there's two operations in the for the first circle and the second circle. Yeah, suppose you get two numbers, not only one. Okay, 60 and 20. Okay. Got it, right? Any other possible ways to solve this problem? Nope, I don't see anything, right? So from 9 to 12, from 12 to 15, you add 3, right? And then from 12 to 16, from 12 to 16, you add 4, 4 to 20, add 4. So maybe that also works, okay? Right? And you can think about different ways. Sometimes you're going across this, okay? All right, right? And so here you plus 3, that's plus 3. That's another pattern, right? So this is a plus 4 and plus 4. Now the question is, what is the difference between those two, right? Between those two is 12, right? So plus 12. Maybe you can also, plus 12, right? So you also get a 60. You see, that's another way you can make sense, right? Right? 48 plus 12. 48 plus 12 is going to be 60. Okay. Yeah. So there are many ways to. So you then end up with the same result. Okay. It end up with the same result. Well, now we're going to deal with the 4 numbers. Right? The 4 numbers. You have a square of 4 numbers. Let me know if you can figure it out. Okay. So 11, 9, 5, 4, 7, 9, 4, 4, 13, 8, 3. Okay, I got 1 answer for this problem. I see that the relationship among those 4 numbers in the first square, right? And then you look at the relationship among the numbers in the second square. Okay, you see that the second column, right, is always 9, 4 and 9, 4. It's interesting, right? So I see that 11 plus 9 is going to be 20. 5 plus 5 multiplied by 4 is also 20. So that means the sum of the first numbers in the first row should be equal to the product of the number in the second row. And let's double check that. Okay, it's 16. And 4 times 4 is also 16. That matches. Okay, the sum of the numbers in the first row is going to be the product of the numbers in the second row. Right? So 13 plus 8. Okay, 13 plus 8 is 21. So 3 times some number should be also 21. And that the number is going to be 7. Yeah. Now, if you can figure out another pattern, let me know. And this is what I figured out. Makes sense. Okay. All right, and now you look at this one. Okay, can you do that now? Great. So as you see that, it's the same reason, right? 9 plus 9 equals 18. And the 2 times 9 equals 18. And you double check that. So second number in the second square. 12 plus 16 is going to be 18. 3 times 6 is going to be 18. So 1 times 18 is going to be 18. And that number plus 18 should be equal to 18 too. So that number must be 0. Okay, great. All right, now have another set. All right. So 9, 3, 9, 3. Wow. 10 fours, 12 fours, slightly different. All right. And some number 6 and 18 is 6. All right, so folks, I think you try, try the difference, right? Try subtraction, try addition, try multiplication, try division. I find out okay, so it's 9. It's a little bit difficult. Okay, so 9 divided by 3, the first rule is going to be 3. 9 minus 3 is going to be 6. Okay, we have to apply the same rule for the second list. 10, hold on, is there any complication? Yeah. 10 minus 4 is going to be 6. 12. Yeah. So let me switch the order. Okay. Because 10 minus 4 is going to be 6. Yeah. So we do the subtraction first. 9 and minus 3 is 6. 9 divided by 3 is going to be 3. Okay. Divide by 3 is 3. And 10 minus 4 is going to be 6. 12 divided by 4 is going to be 3. So actually, see, what happens that we apply the same operations for the numbers in each row in the first square, and then you keep getting 6 and 3 and 6 and 3. Okay, that works. Okay, so then that number minus 6 should be equal to 6, right? 18 divided by 6 is going to be 3. So, and yeah, then you get it, right? That makes sense, right? So for this type of problem, just, for you to improve your, not only just computation skill, everybody knows how to do addition multiplication. You just want to find out some common things among those complicated sets of numbers. Right? Now, if I explain to you this way, okay, that's it, makes sense. All right. We also want to look at this one. Okay. Did I, yeah, there's a slightly change here. 6, 8, 4, 4, 6, 4, 8, 4, 7, 5, 10, 5. Okay. See? Yeah, this is the same, right? 6 minus 4 is going to be 2. 8 divided by 4 is going to be 2. Okay, so 7 minus 5 is going to be 2. 10 divided by 5 is going to be 2. Okay, so that number minus 6 should be 2. 12 divided by 6 is 2. So clearly that number is going to be, right, it's going to be 8. Got it? Great. So now I'm going to discuss some little bit more complicated problems. We only have one square, but there are 9 numbers inside. Okay, watch out. That's a 12, 8, 6, 8, 15, 7, and 4 and 8. Okay, we're trying to find out the missing number. Yeah, there are many ways to get the missing number. Okay, I'm going to draw another picture here. I want to show you 2 different ways to get the same answer. Any different answers? The answer you gave to me is different from my one. Okay, so let me work on this one, right? I look at all the numbers in the first row and the last row, right? I find out from 6 to 7, from 7 to 8, just add a 1. Okay, that makes sense, right? Then also from 12 to 8, 8 to 4, well, minus 4, right? So when it's decreasing, and it's increasing. Okay. And that's probably not the best way to do it. But then from 8 to 15, right? Wait a minute. Did I copy wrong? So I'm sorry. Yeah, this is 18. Yeah, was the origin type is missing here. Yeah, that's it. Yeah. All right, now it works. Okay, sorry for that. Yeah, so when I thought it's 18, yeah, when I was thinking of 18, I didn't write it. Okay, it's 8. Okay, so 18, 12, 15. From 18 to 15, it's actually is minus 3. Okay, right? Subtract minus 3. So I guess the next number should be 12. Okay. 50 minus. Okay. Now, here's another way to do. How that, yeah, I look at each column, each row, right? Among those 3 numbers in each row, 12, 18, 6, 8, 15, 7, right? What's the relation? 4 and 8. So those 2 numbers, 18 actually, 16 is going to be maybe the second number minus the first number. So that'll be 15 minus 8. Okay. So 8 is going to be some number minus 4. Okay. What is the number? That number is going to be 12. All right. That's another way to do. Okay. And I have to double check all the numbers before I talk about it. Okay. So here's another one. Okay. Careful, I'm going to copy all the numbers correct. So 9, 16, 7. Okay, 16, 21, 5. 5 and 9. Okay, this time it's 100% is correct. Okay, so let's figure out the missing number. Thank you, Oliver, Morgan. Michelle, great job. Right. As you can see that, yeah, you can look at all the columns one by one. You can look at the, look at the rows. Okay. Sometimes there's no pattern among the rows, right? 6, 9, 16, 4, and 7, 5, 9, I don't see any. Yeah, those two columns do not, yeah, they're not similar. Okay. There's a number in the middle, right? The first column, is larger. The second column, the number in the middle is 5. It's less than that. So let's look at the columns. I find out 9 plus 7 equals 16, right? And 16 plus 5 is going to be 21. So the missing number 5 and 4 plus 9, that's going to be 13. So 13 should be the answer. Okay. All right, so let's see one more problem. Okay, 8, 17, 5, 10, 11, 9, 12, and 16. So let's find out the missing number. This is a magic box, to tell the truth. Okay. Yeah, this is called magic square, magic matrix. All right. Okay. Anyone have an answer now? You shouldn't use the same method we calculate the numbers in each row, okay, from above examples. Yeah, you should look at all those numbers in each rows or columns to see if you can figure it out some patterns. Yeah, Oliver, great job. Right, so several of you get answers. Okay, let's see. We find out the sum of the numbers in each row is going to be 30. Okay, so 10 plus 11 plus 9 is going to be 30. So some number plus this is going to be 30. So that number should be equal to. Okay, now you can also look at the column 8 plus 10 plus 12. That is going to be 30, right? So 5 plus 9 plus 16. 14 plus 16 is also going to be 30. So 17 plus 11 and plus, I think plus 2 should be equal to 30. So this is a special square. The sum of the three numbers in each row is going to be 30. The sum of the numbers in each column is also going to be 30. Now, can you make another one like that? The sum of numbers in each row are all equal to each other, and the sum of the numbers in each columns also, they're all equal to each other. Yeah, it's not easy to make one, okay? But this is a very nice example. All right. Now the next one, it's a little bit difficult. So I have a 4, I have a 9, 11, 6, 24, and 7, 35, and 30. Now, can you do this? Find the missing number. Okay. Great. Morgan, you can answer. Okay. Eric, double check your work. Okay. You're close, the answers. Thank you. Yeah, you should post the answer if you get one. Okay. Don't be shy. All right. Now you can add all those three numbers together, but I don't see any patterns, right? So 4 plus 11, you know, I try this and yeah, let's take a look at this two rows. Any patterns you can see. 4, 9, 11, 7, 30, 35. Okay. All right, so 4 plus 9 is not going to be 11, 13. Let me write down this first, okay? And 7 plus 30 is going to be 37. So 37 is not 35, right? And 13 is also 2 more than 11. Okay, sounds good. So that means the middle number plus 2. That means the middle number plus 2. Okay, if you see that, then you probably can solve the problem. 6 plus some number should be 24, but 24, right? Not the 24. That's we should get 24 plus some number. It's 26. Okay. Right? You should get 26 because the middle number plus 2. Okay, so that's why the missing number is going to be 20. All right, that works. All right, so it's a little bit complicated. All right, so we're done with finding missing numbers. Now let's try to do some computation, find some new patterns. Okay, what do you mean new patterns? All right, so someone, you know, had lots of time, he practiced and he looked at, okay, he found out now 21 minus 12, that's 9, okay? I just switched the order of the 2 digits, okay? And then you know, 23 my 20, yeah, I'm going to use the first digit should be larger, otherwise I get a negative number. Okay. So for example, 31 minus 13, what do you get? Right? 31 minus 13 is 18. Okay, so you plug this minus 31 minus 18 is 18. Right, so 18 is a multiple of 9. I multiply by 2. Right, then I use a 42 minus 24, right? I switch the order. So what do you see? 42 minus 24. And I also get 18. Okay. Just like doing scientific research, you know, at the very beginning, you feel boring and they just do some subtractions. And then you have to be alert to what you see. Okay. Then you probably discover some new theory, you know. That's how do we do the research, right? So I'm going to try another one. I know I start with boring. Then I say 53 minus 35. Okay. Yeah, this is an example show you how do we do the research. Okay. So at the very beginning, sometimes you just try do some experiment, right? And then you probably that's not your motivation to find, you know, original motivation. You just do some computation for other purpose. Then you find out that that's also 18, 2 times 9. Now the question is, so far we only get 9 and 18, right? So how about 51 minus 15? Okay. Now this time maybe I got different number. Okay. 51 minus 15. Yeah, 36. But 36 is a 4 times 9. Okay. So I get 4 times, but they're all multiple of 9. Okay. Maybe 91 minus 19. Okay. 91 minus 19. Okay, it's a 72, right? 72 is 8 times 9. Okay, 72 is 8 times 9. So at this point, maybe you can tell, tell your mommy, hey, mommy, I find some pattern here. If I switch the 2 digits, I take a difference, I find out it's always a multiple of 9. Okay, can you even find more information from this? Okay, so the last digit is always 9. But how about the 8? Can I find the 8 before even do the computation? I find the 8 is just the difference of those 2 digits. Okay, so the difference of these 2 digits is also 9 minus 1 times 9. Okay, and this is a 5 minus 1 times 9. And this is going to be 5 minus 3 times 9. So that's another discovery, right? So now you probably can end up with a theorem. Okay, so then do more, one more. Okay, 83 minus 38. I'm supposed to get, right, 5 times 9. Okay, so if that is true, then my conjecture is correct. In mathematics, when you do the research, right, and sometimes you find you do look at some examples, and you find out some pattern, then you make a conjecture, then you have to prove that. Okay, that's the way, several steps, in scientific research. Okay, so 83, right? 83, minus 38, yeah, it's going to be 45. 45 is 5 times 9. And yes, that's going to be 8 minus 3 is 5. So now you have a general statement. In mathematics, we make a conjecture, right? So if you cannot prove it, you publish, okay? And if your last name is Zhang, and that's called the Zhang's conjecture, right? So AB minus BA. So we assume that A is larger than B, right? Otherwise you get a negative number, switch the order. So this is supposed to be the difference times 9, right? That's our statement. Okay, Now you may be able to prove it late, right? So but you find the formula, but without the proving it, you cannot use it because maybe it's not true for other problems, right? Okay, and until of course after you check all of the digits A, B, then if it still works, then you can say that, but they usually don't have a time to check all of them, right? How many different, how many two-digit numbers there? Question, how many two-digit numbers there, right? The number, how many two-digit numbers there, right? So the number of two-digit integers is going to be 90. Right? Yeah, this is called the conjecture. We call it conjecture. Yeah, 90, because 99 minus 9, that's 90. So that 92 two-digit integers there. So you cannot check all 90s. You don't have a time. Okay. Yeah. So I call the conjecture until you prove it. So I'm going to show you how to prove it. Remember 21 in mathematics can be written as 2 times 10. Oops, my file is gone, so I'm going to bring it back, okay? So don't be panicked. Yeah, sometimes when I touch somewhere, it's okay now. You should see that, okay? So yeah, 21 in mathematics, you can read as 2 times 10 plus 1. Okay, right? 21 is 2 times 10 plus 1. And and like 32 is 3 times 10 plus 2, right? Now, if I just use AB as a two-digit number, you can express it like a 10A plus B. Yeah, that's the first time probably you have to deal with the variables, right? If you don't understand that, it's okay. We can do this later, okay? So BA, if we exchange these two digits, it's going to be 10 times B plus A. Now, if we involve variables, I don't use a clause as for the multiplication. You know why? Because easily confused with X. Okay, this clause. Yeah, sometimes looks like handwriting, looks like X. So usually we don't use a clause as a multiplication. We use a dot sometimes, okay? But sometimes even you don't need to mention dot here. Yeah, dot, this means product, okay? Then let's take the difference, okay? Yeah, so it's 10 dot A plus B minus, some of you can understand because you already learned this stuff at home. And then I put the parenthesis B plus A. Okay, then you remove the parenthesis. When you remove the parenthesis, you have to change the sign for every term. Then you regroup them, you find out you have a 10A minus 1, like a 10 apples minus 1 apple, you have a 9 apple. Okay, now B minus 10, just like a 1 minus 10, it should be negative 9B. Okay, so you see, then you take 9 out, but you can put a 9 on the right hand side, on the left hand side, doesn't matter. So that's why this is always true, right? All you have to do is just take the difference of the two digits and multiply by 9. So now you double check, right? And 72 minus 27. All you have to do is just 9 times the difference of those two digits, 7 minus 2, which is 9 times 5, okay? And the 45, okay? Great. Now, Then you say, okay, I take a difference. How come if I add them together? Okay, let's try different, right? And the 21 plus 12, I got 33. 33 is going to be multiple of 11, right? 3 times 11, okay? And then 43 plus 34, I got 77. So every time I got 11, fact multiple of 11, right? All right, let's continue. And 38 plus 83. So I got 121. 121 is 11 times 11. But how to get 11 here? 11 actually is in the sum of the digits. And here 7 is the sum of digits. And the 3 is also the sum of digits. So now you can jump to the conclusion. But when you do research in biology or chemistry, probably you already conclude that should be always true. But in mathematics, you have to prove that, okay? So we can say claim, AB plus BA should be A plus B times 11, right? Yeah, if we switch the order of these two digits, add them together, and you should just add those two digits plus 1. So you discover another formula by yourself. And then you test it. If testing it's okay, randomly pick up numbers, and the 52 plus 25. And then this should be 5 plus 2 times 11. And you double check that works. And then if this is an experiment in the biology, then people publish a paper here based on the experiment. And then this experiment can be repeated, result will be the same. And then that's our result, okay? That's called science, okay? But the mathematicians are not satisfied with this kind of thing. So you have to give a proof. And I'm not going to repeat or give a proof. I don't have time. So you cannot assume A, B are special numbers. You just assume A, B are digits, arbitrary digits. Okay, and then just like what I did, I proved that, the sum of those two integers, if you switch the order, and then you get A plus B times 11, okay? And only after you prove that for general digits, then you can use it and you can call the formula. And can you publish a paper? Otherwise, you cannot publish a paper, okay? I just want to tell you that research in mathematics and in chemistry, biology, they're quite different, okay? All right, and there are many, there are many interesting patterns in mathematics. I'm going to show you one here, another one here. You see, 1 plus 0 times 9 is going to be 1, okay? No problem. How about I increase this number, 2 times 1 times 9? And that is going to be 11. Okay, you get double ones. All right, then I got 3 plus 12 times 9. And then I got compute it, okay? 12 times 9, okay? 12 times 9, you can check. Let me double check, okay? So 12 times 9 and plus 3. Yeah, it's going to be 111. So what I'm trying to do is try to get the sum, trying to get a result, increase the number of the ones, okay? So I have a 4 here, and that from 1 to 12, now it's 1, 2, 3. That is another interesting identity. So you can, now what you can do, so you can conjecture, right? This should be 5. And here's 1, 2, 3, 4 times 9. And then use a calculator, okay? Because you don't have a time to do the computation here. So if you use a calculator, 1, 2, 3, 4, right, times 9 and plus 5, and surprised, and that is still going to be like, it's just as you predict. You just get the one more digit, 111. So let's continue. 6 plus Okay, 1, 2, 3, 4, 5. And I'm pretty sure you have 1, 2, 3, 4, 5, 6. Okay. Okay. And the 7, 1, 2, 3, 4, 5, 6 times 9, get 1, 1, 1. Okay, you have 7 ones. And 8, 1, 2, 3, 4, 5, 6, 7 plus 9. You're going to get 1, 1, 1. You get 8 ones. I think we probably have to stop somewhere because we only have a limited digits here, right? And then, right? So you're going to be 9. 1, 2, 3, 4, 5, 6, 7, 8 times 9. I should get a 9 digits. 9 1, 1, 1s. Do you think this pattern will be continued? The problem is that, you see, we only create 10 digits from 0 to 9. So I probably can, otherwise you have trouble to write down the numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's okay. Multiply 9. And I hope this is 2 digits enough. But after that, it's harder to continue, extend this number, right? So I'm pretty sure, yeah, we stop here, and that is what we discover the pattern. Okay, so here, like 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9, yeah, plus 10, yes, great. Okay, so those are the numbers that we discover, and maybe you can discover something, interesting. Okay, and let me know if you find that. But I have still a few minutes, so let's continue. Okay, trying to find some patterns. Okay, so I'm going to do this one because we got so many interesting numbers, right? So I'm going to use a 1. 1 times 1, okay, is going to be 1. 1, 11 times 11, I got the 1, 2, 1, right? That's okay. Then how about I have 3 ones here? And you can use calculate, okay? Then I find out I get a 1, 2, 3, 2, 1. Yeah, this is a pretty symmetric number, right? Then I have a 4, 4, 4, 4. A 1, 1, 1, 1, yeah. And you get 1, 2, 3, 4, 3, 2, 1. See, that's why. So now you can get some kind of pattern. Depends on how many digits do you have, right? So my conjecture here is if we have a 9 digits, okay, here's 9 digits, multiply 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so you have a 9 here, 9 here, right? So I should get 1, 2, 3, 4, 5, 6, 7, 8. And 9 should be in the middle. 8, 7, 6, 5, 4, 3, 2, 1. Now, so I think those are very interesting numbers. Sometimes we can use this as like a password, but you don't memorize the password in a file directly write down because people can easily decode it. Okay, instead of you memorize, instead of you write down this number on the right hand side, you write down 111111111. That's my password. Okay, because people don't know how to get from this one from that one. At least it's not. Of course, they use a software, maybe still can figure it out, but at least it's ordinary people cannot easily get it. But you remember all the password you get is a square of your number you write down on the document. You see, that's useful. That is the use of mathematics. So every time you forgot the password, go back to look at what you see. Oh, for this account, my password is 9 ones, but that's not the real password. You know that you just have to square. So all you have to do is memorize this, record this number, but also memorize the formula you're using to create another number. So then you see, then you the true, then you figured out the real password that you're using. Yeah, you shouldn't directly write on the password on the book. Okay, then people can see that, oh, that's my Gmail account, the password, right? And it's, like a number, it's easy. Then people just copy it and take a picture, then they can use it. So you probably don't need it to do that. You just write down a number like a 24, 124, but that, that 24 is not the number, real number in the password, 24 cubed maybe. To get another number. So when you see 124, then your password will be 124 cubed, and you get a 2 cubed, and then that is a real password. So people will not figure it out easily. Okay, so that's a useful of the mathematics. You can see that mathematics are useful in many areas, and that is your motivation to study mathematics here. Your parents wish you to learn more mathematics, and of course, many parents can help you, but sometimes they're busy. They don't want to teach you everything, So that's why they want you to study with me. But they will help you to solve some homework problems. But you cannot just turn to your parents for help unless you spend 15 minutes on some problems you still cannot figure it out. Maybe get a hint from them. Okay, then continue work on that problem. Only until you solve it by yourself, you will memorize it. Okay, and you will do better in the future. Okay. Okay, so I'm going to stop here and wish you to have a good weekend.